Hello algebra students, this is Miss Ozanich, and today we're going to be talking about function notation. And the first thing I'd like you to take a look at here on our screen is just how these two expressions kind of look the same. And what I want you to notice is I want you to notice how this X has changed to a heart right here, right? And then this X has also changed to a heart. And this X value has also changed to a heart. So it looks like what has happened is whatever picture has gone in here into this spot for X, we have gone ahead and replaced that picture everywhere we saw an X. Do you see that happening right there? So when we talk about function machines and applying a function to a set of X values to get a corresponding set of Y values or values of the function evaluated at X, you just have to make a replacement. Okay, so we're going to look at this in a lot of different ways real quick. I wanted to show you this idea as a table. This notation that you see right here, this crazy F parenthesis X parenthesis, means function evaluated at X. So a lot of times we have plotted points on an XY table that have to do with plugging X into some kind of formula. Okay, so this f of X is replacing our Y. Okay, it's just a way to talk about our function. It's going to have a 1-to-1 correspondence. That means every value of X that I plug in, for example, 3 times 0, is going to be 0, is going to have a corresponding function evaluated at 0. So that's going to be the point 0, 0. We can plot that point. 3 times 1, if we picked X to be 1, then 3 times 1 is going to be 3. And then if we picked X to be 2, 3 times 2 is 6. So this column is going to be our input column, and this column is going to be our output column. And as you plot those points, you can see it forms a function. Okay? So a lot of times when we're starting to learn about functions, right, we are learning about what it means to have some kind of a formula. In this case, the formula is 7 times X applied to all of our inputs. So our inputs, we're going to put a number in here. That's going to be our input. A number is going to come out after this operation is applied to it, and that is going to be our output. So we're just going to practice a couple with 7x. So if our input was 3, our output would be 3 times 7, or 21. Okay. If our input was a -1, we would multiply -1 times 7. Our output would be a -7. Okay. Let's try the input and output on a couple other function machines. Here's another one. The rule is -2x minus 1. So if my input was 5, that 5 is going to drop into my machine. It's going to get multiplied by a -2. That makes a -10. We're going to subtract one more, and then out is going to shoot the number 11, -11. Let's try another one. What if we had an input of -3? So our negative 3 goes into our function machine. Negative 2 times negative 3 is a positive 6 minus 1, and our output is 5. Okay, so the way this looks in terms of the notation is like this. If you said, I'm evaluating the function at 5, then what happens is my 5 goes into the place for x. And that's how I get my negative 10 minus 1, or f of 5 equal to negative 11. All right, let's try one last function machine over here on this side. And the rule for this function machine is 3x plus 4. So we're going to drop a number in here. Let's drop in the number 0. Okay, let's see what happens as that 0 comes into this function machine. 3 times 0 is 0, plus 4. The output would be 4. Okay, let's try another number. Let's try a negative number this time. How about a negative 6? Let's drop that negative 6 right in there. 3 times a negative 6 is negative 18. Negative 18 plus 4. The output is going to be 14. So again, this is how your algebra would look if we're taking the function, this is shorthand, remember, for the function evaluated at negative 6. And everywhere we see an x, we replace it with our negative 6. Okay, so we continue to simplify. And we get our negative 18 plus 4 is going to be negative 14. And I apologize before if I didn't say negative 14 on that one as our output. You guys are probably thinking, wait, Miss O, it has to be negative. All right, and if you were thinking that, good job. Okay, so as we're thinking about function notation, I have one more example I want to show you. And that is how you can evaluate a function given a graph. Okay? So what we're going to do is we're going to find the function evaluated at negative 2. We're going to do this one first. And so what we're going to do is we're going to look for negative 2 on our x-axis. Okay? And try to see if it actually corresponds to a 4 on our y-axis, okay, or as our y-coordinates. So let's go over here and check. If I come over here to negative 2 as an x value and I go up 1, 2, 3, 4, yes, in fact, that is true. So we can say f of negative 2 equals 4. Let's try this one right here. Let's go to 0 on our x-axis and see if the corresponding point for y is going to be 3. Let's see if this one's true. We go to 0 on the x-axis and we count up 1, 2, 3. There it is. That's the point 0, 3. This was the point negative 2, 4. So if I asked you to evaluate, for example, let's try one together here. What if I said, what is f of, let's try negative 3. This one's not given in our current picture, so let's see if we can figure out what f of negative 3 would be. So we go to negative 3, negative 1, negative 2, negative 3. And then we look at the y value that corresponds to that. Probably maybe 2.5, maybe not quite 2.5, but we could say it's about 2.5. Okay, so this is our x value, this is our corresponding y value. And that's how you work with function notation to analyze your graph. All right, I hope that quick video will help you guys with function notation, and let me know if you have any other questions or need any help with your homework. Thanks, guys.